Breaking news from BA News Station. This is an emergency announcement to all human occupants on Earth. There is a massive asteroid coming towards us right now as we speak. This asteroid is coming towards us at record speeds, and Earth is already feeling the effects of the heat coming off of the asteroid as it keeps getting closer. The reason for this is because the closer two objects are to each other, the stronger the gravitational pull between them is. The reason the asteroid is so threatening is because once an object is in motion, it stays in motion until it is acted upon by an unbalanced force. And there is nothing in this asteroid's path that could slow it down as of right now. This asteroid is accelerating very quickly and is packed with tons of mass. If it does not slow down quick enough, Earth will be struck with a very high amount of force. If this happens, then the human race as we know it might come to an end. Now off to Brock explaining the math behind the asteroid.
Thank you, Allie. Back in the office, we will now discuss some of the mathematics associated with this asteroid. As a matter of fact, I feel as if this asteroid is getting closer and closer, and we might need to take cover soon. Thanks to Sir Isaac Newton and his law of gravitation, we have an equation that can help us solve the force of gravitation between two objects, in our case, the Earth and this asteroid. The equation for this is 6.67 times 10 to the negative 11th, and that number is a gravitational constant, times the mass of the first object, which would be the asteroid, times the mass of the second object, which would be the Earth, divided by r squared, which would be, r would mean the distance between the two objects. So we got to plug in our numbers. First we have 6.67 times 10 to the negative 11th times 2.8 times 10 to the 21st in kilograms times 5.972 times 10 to the 24th kilograms divided by 6,500 kilometers squared. After we plug that into our calculators, we get 2.64 times 10 to the 28th newtons. That is the force of gravitation between the Earth and the asteroid. The force this asteroid will hit us at is calculated by mass times acceleration. To calculate this, for our asteroid, its force equals the mass, which is 2.8 times 10 to the 21st, times 10.88 kilometers per second squared, which is the acceleration. Then we calculate the force, which is when we multiply them together, we get 3.05 times 10 to the 22nd newtons. Oh goodness. Oh, I guess we gotta take cover.